Hey team, welcome to the session on Coffee with Prab. And we have Mr. Sinclair with us. There's no need of introduction. He having a 45 plus year of experience in the OT security, and currently he do a lot of training and consulting on physical security, process securities, OT security and all that. One of the best thing about Mr. Sinclair is about the write-ups and the content which they share on LinkedIn, and lot of OT security professionals are basically admire Mr. Sinclair on their work in their OT security platform. So thank you, sir. Thank you for your time for this particular session, and we are really grateful to have you in this particular channel, sir.
Well, thank you for inviting me and giving me the time to talk about my favorite topics. So it's, yeah.
But Mr. Sinclair, I would like to give a personal thank you for this, because I'm following you from last 8 years. Okay, so when you're working for your previous industry, previous company, and about your write-ups, your experience you share on OT security, it was just really amazing. And I'm sure the way I got inspired from your content, a lot of OT security professionals, will definitely love this content, which we're going to discuss in today's session. And thanks for taking out the time from in a weekend. I know weekend is basically something is a family time, and taking out this for the society is really commendable. Thank you, sir, again.
No, that's fine. That's fine.
So Mr. Sinclair, just need to understand from you. So what is the topic that we're going to discuss today on OT security?
I would like to talk about a topic called deep defense.
Wow.
That's something different as defense in depth. I will hopefully be able to explain that. It's a topic I'm writing a book about at the moment. So it's I'm recently retired from my professional career. So I do still work. I do provide various courses to different companies, but it's not anymore on a full-time base.
Great. We can see a lot of initiative from your side in future then, I believe so, the way you're working on the content and all that.
Yeah. But that's my topic, deep defense, and I would like to explain what I mean with it, why it's important. It's not so technical. It's not going to talk about firewalls and all kind of security measures that we can take, but it's more an overview.
So I will basically make you presenter, and by that you can able to share your screen, the PPT that you have prepared. Give me a second.
Yeah.
So I gave you the presenter, right?
Okay, so if I open my slides, you will see that now.
Wow, what a great PPT. Deep defense, managing a crossover cyber and process safety risk. So, sir, I just want to say something. I haven't seen such content or as a title in YouTube, so I'm sure it will be very fruitful session, at least for me.
Yeah, okay, I needed to, like I mentioned, I'm writing a book at the moment. I'm retired, so I have all the time in the world to document all the things I've learned over the past years. Like you mentioned in your intro, I'm 45 years active in process control environments in OT, though we didn't call it like that 45 years ago, but only, I would say, 21, 22 years in cybersecurity and networks in that area. Before that, we had proprietary networks and things like that. So but there were different times. And in that period, I developed my skills in cybersecurity. The last, since I guess 2014, so that's the last 9 years.
Okay.
I spent on cyber physical risk assessments. And with that, the concept of deep defense kind of came on top. What do I mean with deep defense? I can show you that in hopefully in the next slide. In the next slide, I try to explain what it is. Actually, if you look at risk, then you can focus very much on the automation system, on the technical components, the controllers, the servers, the network equipment used in the automation system, and that we call OT technical risk. And if you look at our discussions on cybersecurity, there's a lot of focus on that part.
Okay.
But there is also something called for cyber physical risk, and then we actually increase the scope with the installation. So the pumps, the vessels, the furnaces, the distillation pumps, and actually that is the target for most of it. It's not always, of course, when you have a ransomware type of attack, which can potentially hit the automation system. It didn't happen that often, but it can. Then, okay, you stop the production. But with cyber physical risk, you actually try to damage equipment. You might try to damage a pump. You might try to cause some explosion or some leak of toxic vapor, things like that. The real bad things. That is what I call cyber physical risk. So that includes the process installation, and then you can go even wider than that, which makes it more difficult by also adding the human factors and the organizational factors. And then we talk about socio-technical risk. And deep defense is looking at, at all of it. So it doesn't stop at the idea that if you have a very good security protection of your OT technology, of your automation system, your industrial control system, that is the end of it, because that can fail. And then you can still have an impact on your cyber physical part, on your physical part. So it also looks at how can we improve security by improving that. For example, you can damage a pump in a system very easily by closing some valve on the suction side. And the pump is trying to pull in material, but it doesn't have any material anymore. So it starts increasing its speed, starts overheating, and might damage the pump at that point in time. But that type of thing is easily prevented by having some overload protection installed in the pump. And so there are many ways that even if the cybersecurity fails, that we can still prevent cyber physical damage. And it's the same with looking at the human factors, the organizational parts. That's also introduced sometimes security issues, which can be prevented. And so it's a kind of a holistic look at cybersecurity. That's what I call deep defense. So looking at all the aspects of security and not only at the firewall, at the Cisco switches or whatever type of network equipment you're using. It's more than Windows and network. It's more than the software. It's also including the physical stuff. And if I compare that with what is defense in depth, some people might confuse those things.
I was about to ask that question. Yeah.
Yeah.
Is it different from defense in depth and all that? Yeah.
Well, defense in depth, of course, is an important thing also in defense, in deep defense. But defense in depth looks at creating additional layers of protection that prevent when one layer fails, that at least there's a next layer that will hinder or stop the attacker. That's something different. Deep defense is really looking to increase the scope of security, which parts can impact security, where defense in depth is a security mechanism, where you stop the attacker by having multiple security measures in place. So when one measure is breached, that the next one will stop him or at least delay him so that you can detect him. So there are differences in that, and so I'm not talking about defense in depth. I'm talking about deep defense, which is more. You might say it's a scope. It's using the scope and not so much looking at that. But yeah, the names are confusing. Okay, what if I look at risk? I'm guy looking at cybersecurity from a risk perspective. I'm not that much looking at the actual way of we configure security measures and how we segment our network and all that. I look at it from a risk perspective. So when you identify the risk and you identify the sources of risk, we'll call the hazards, then we can also mitigate that risk based upon which is the highest risk. That's important because it's almost impractical to protect against all types of hazards. Some are more important than others, and you have to identify that. So, and if you talk about risk, the risk is always probability times impact, right? Chance times impact. That is the formula. And if I look at the left side of the probability side, well, what are the risk factors for probability? Well, one of them might be the threat landscape.
True.
If you are facing very strong threat actors, maybe even nation state type of threat actors, then you're in bigger trouble than when that is not the case. So that's one factor. Another factor is exposure. A threat actor always needs to have an exposed system. He needs to get into contact somehow with the system to be able to attack it, to breach it. So exposure is important. Exposure, of course, relates immediately to what we call attack surface. The bigger the attack surface, the bigger the exposure. And but it's not only attack surface. There are other factors too.
So what are the other exposures we can say? Because if you're talking about the IT security, we have a lot of exposures from the external traffic, the DMZ, and we have a lot of issues from the intentional errors and all that. We have exposure factor from the IT point of view. We have exposure factor like DMZs. We have a lot of exposure factor from the politics, dynamics, technologies, and all that. So how we take the exposure factor from an OT security point of view?
Well, it depends a little bit on how you look at the cyber attack. It makes a big difference. Exposure makes a big difference if you look at the threat actors from an external point of view or from an insider point of view.
Okay.
Your system is very much exposed to any type of insiders. Depends then even on the how privileged the insider is, how exposed you are. So if your system admin would be the threat actor, and you are very exposed.
Understood.
If it's just a visitor, then you're less exposed.
True.
But yeah, exposure has to do with attack surface, so it has to do with how open is your firewall if you look at it from the outside, how well hardened is your node, so how many services did you disable, and all that type of elements play a role.
Consider. Okay.
Yeah. Also, your network segmentation limits exposure.
Okay.
So that's an important factor. Complexity is another important factor. The more complex, the more vulnerable. Because software errors, they're almost not to be avoided. So how more software is in a system, how more software components are running in a system, the more likely it is that there will be a vulnerability that might be discovered at one point in time and exploited.
At least we have a visibility in the IT, but when it comes to the OT networks or when you're talking about the physical security, we have a very limited visibility, which lead to the complexity. So, Mr. Sinclair, like how you overcome that complexity issues if we face in the company? Because not necessarily, I join a company and there I'm going to build the OT systems and physical security and all that. So if I join a company which already have the traditional OT systems and all that, and very well, it's a lot of complex architecture we have. So how as a security consultant, how as a OT security consultant overcome these issues? What is your recommendation for those people?
Yeah, that's a bit difficult question because I have been working always in an environment. I've worked for a vendor company. And as a vendor company, we of course know how the systems are built, what's in there, and we know probably more than is published. You work, your systems fail, you learn things over time, so you have a good impression on that. But if you look at complexity at all, in a very simple terms, if you have an application that uses some a web interface or some database or some other technology, then it's far more complex than if you have a process controller which uses proprietary software, which is much more limited in its capabilities than if I would have some historian server or some alarm management server.
Okay.
With a lot of web interfaces. So complexity, yeah, it is hard to give an objective score for it, but you will understand that a Windows server is certainly more complex than a field instrument. To
True.
give the extreme.
That's true. Yeah, but sometimes we have to understand the business requirement also, because we cannot go for too much secure environment and all that. Yeah, I understand, because when it comes to OT, we are very more concerned about the availability and accessibility and all that. So I do understand that. Yeah. So next is human factor and resilience. You're talking about, sir, something.
Yeah, human factors are of course important. The awareness of people. If you work with a team of people that is not so security aware, the probability of a security incident will be bigger than if that's not the case. Resilience has to do with how easily recovers a system, how well is everything organized, and also a little bit looking at your cybersecurity measures that stop attacks. That plays a role in your probability. The software hardware quality, in the sense.
I believe that was the most important probability, because we don't have any control over the configurations or the device configuration from the vendor.
I always had when you work for a vendor, that's not a very good joke, but we always had the joke: never buy a release 100. The first release is always with some more problems than if you buy a release 500 or something like that.
True.
Things work out over time. So software hardware quality is an issue. And there are, for probabilities, also dependencies. Some systems depend very much on other systems, other processes. So dependencies are important for probability. If you look at the impact side, well, criticality of the process, of course, is important. How more critical, probably how higher the impact. The operational impact is a role. You lose your production, maybe.
True.
And that also goes back to criticality in the sense that some people might depend on your service as a plant. Safety is of course important, because there are human life at stake at that point in time. Environmental impact is of importance. You can have all kind of bad leakage, toxic vapors coming out. Financial impact, though everything translates to financial impact, I guess. Operational impact, safety impact, environmental impact, that's all resulting in the end also in financial impact.
Great.
And less easy to measure is reputational impact. If a company gets bad news, their shareholders probably don't like that.
True. And it is very difficult to calculate the reputation impact, because it can go high, it can go low. We don't, at least we have a financial impact, environmental impact, safety impact, we can able to calculate. But in the case of reputation impact, it is difficult to calculate. So how you overcome, because you are in the industry and you are handling the OT part from 20 years. So how you overcome, because I'm sure you have seen a lot of breaches, a lot of issues in OT also, like starting with 2012. Then recently, a lot of things was there where they targeted the nuclear plants, and right now the clash is happening between Russia and Ukraine, and we can see a lot of things are coming in the OT. So one of the concern we had from a customer point of view is the OT security from reputation impact. So As a security professional, as a consultant, so what is your recommendation for the people who are watching this video, like how we tackle the reputation impact and the operational impact in the OT?
Well, to be honest, I've done more than 20 risk assessments for different chemical plants and refineries and offshore. But reputational impact we never included. We always excluded it. I put it on the list because it's of importance, but it's very hard to measure.
Okay.
And it is even harder to mitigate. I mean, it's never our work. In that sense, I'm a very technical person, and when we talk about reputational impact, it's not very technical area. It's I would say it's a whole different area, but okay, it's important. I mean, reputational impact. If you do something, you can have a bad name. It happens.
Because a lot of companies sell their solution based on reputation, and for them that is the most important thing. Like
that's true.
So the way you're conducting a risk assessment in the OT, like, is it the same way we do the assessment, like the way we do assessment for the IT processes and all that, the same way we drive the risk assessment for the OT also?
No, it's actually totally different, I would say. And now I talk about cyber physical risk type of assessment, which is not done in the IT part typically. Typically, IT part doesn't look at those areas. Our risk assessment also depended very much on the input from the safety process safety hazard information. And in process safety hazard information, plans typically only focus on finance, environment, and safety parts. And that are the three, and operational, of course, but operational translates very easily into finance. A reputation is also there, and in a safety hazard, you typically don't find the reputational impact score.
Okay.
And so that is, how we link those two. But it's different from IT risk assessment. IT risk assessment is not so much into that area. IT risk assessment would be very much comparable, maybe when you focus only on the OT system, only on the let's say the computer part of it, the software part. But the moment you also look at impact on the installation, then risk assessments start to differ very much in how you approach it. So these are the factors that play a role in cyber physical risk.
Great.
And these are the factors that you can use to reduce risk by influencing those.
Okay.
Let me go to the next one. And
I'm sorry for asking so many questions. Sorry for that.
No, that's fine. I'm fine. It's always good to have a discussion and not a broadcast only.
Yeah.
What are the disciplines that influence this risk? Well, there are many. And when I talk about discipline, I'm looking at teams working in a plant. Process operations, that are the guys that operate the production process. They set the set points and everything else in that area. They of course have a big impact because they
but the way we're talking about in information security, culture is most important thing which influences security. Is it same applicable in the OT also, sir? Like, is the culture really matters? Like we talk about security cultures of reporting this incidents, perceive the best practices, even we have a technology, we respect that. So are you talking about the same thing here in disciplines? Like, what is the disciplines that influence in the OT security?
Yeah, I'm not 100% certain I understand the question.
The question is, when you're talking about in the information security, we say culture is important. Culture is like, we promoting a security best practices. If user finds some suspicious activity, he report the incident, then following the policies thoroughly. According to policy, he maintain clean desk policy. Okay, so this is called as a security culture, which is set up by the management. So are we talking about the same thing in OT, which called disciplines that influence the OT security? What exactly?
If I talk about discipline, I'm not talking about discipline in that meaning. I'm more talking about a discipline where a group of people with a specific skill set and a
Okay.
specific task.
Okay.
But of course, what you mentioned, that type of discipline, the awareness, that's important everywhere. But I'll actually come to that because there are people, of course, responsible for that part. But process operations team is very important because they have privileged access to the system, so they should be careful with their credentials. If they use USB sticks for information transfer, they should be careful on how to do that. Process engineering, of course. Process engineering, these are the guys that actually build the process, the automation process. How do you control an industrial furnace? How do you control a distillation column, a boiler, pump? These are the guys that build those applications. They and you can actually improve your security by making certain design decisions. If you look at security in that sense, and traditionally process engineers looked only at the production process and not so much at how can we create our design in a way that it's less vulnerable to cyber attacks. They rely a little bit on, well, the OT system should be secure, and we have no task in that. But actually, some of the design decisions they make the system more vulnerable, make it more exposed in some ways. So that is an important discipline. I'm not going to explain in this presentation all these details on how process engineering is going to do. That's actually something I do in my book.
Okay.
In my book, I'm coming with.
And when you're planning to release that book, Sinclair, like, just need to understand.
Well, my publisher wants to have it end of the year or ultimately end of first quarter next year. But,
okay.
It's hard work.
I don't understand. It is more difficult than doing training, I believe, because you bring all the inputs and all that. I do understand. Yeah.
That's why I focus primarily on the book. Typically in the plant, you also have a process automation team. And that is the team that is actually taking care of all this OT technology. They make sure that it works. They make the backups. They make if components fail, they repair it. So that's the process automation. They're typically responsible for what we call the SCADA or the DCS system. Then another team in a plant is typically field instrumentation. Field instrumentation, they take care of the analyzers. They take care of the transmitters in the field, the valves, the positioners, all that type of equipment is in their control.
Okay.
Also, very important for cybersecurity. They make the decisions that might increase the exposure of a system. And one of the key things of why I think deep defense is important is that when you go to a plant today, very often you see that all these groups I'm talking about now work in isolation. And they say at a certain moment, cybersecurity is responsible, process automation is responsible for the cybersecurity, but they cannot be the only one responsible. So all of them have influence, and that is the thing that deep defense is trying to talk about. Of course, you have a process safety team, which is a different discipline. They're looking very much to the safety of the system. Though the safety instrumented system is often under management of the process automation team, but their importance is in how to safeguard systems.
Informations, yeah.
You have, of course, always a maintenance team, a reliability team. In this context, it's more the hardware, the installation type of maintenance. But also they impact on cybersecurity.
Okay.
Then information communication to ICT. Of course, I don't really mean with that only network, but there is a lot of ICT in a plant, all kind of communication links, also with external environments, and then typically a different team is taking care of it. If you have a plant-wide network, they might also maintain that. If you have a plant that makes its own power, you have a power operations team, all under discipline. With a lot of, all of these environments have their different systems that control it. The ICT team might have some advanced communication technology, might have radio connections, might have satellite connections in some cases. The power operations team, of course, also have their power management systems to control. All network connected, so potentially vulnerable. Procurement is a team. Procurement, of course, starts the whole thing. What procurement influences very much what we call the request for proposal. So if you make a request for proposal to a vendor of a SCADA system or a DCS system, you should specify some security requirements. Because if you don't specify your security requirements very clearly, then every vendor tries, of course, to keep its price as low as possible for competitivity reasons. And if you don't specify it clearly, then security becomes very often a kind of a cost saver.
Agree.
And so procurement is very important in all aspects, also in selecting the right partners and not buying equipment from anyone. There might be all kind of supply chain type of attacks coming that way. You have also on the left side now laboratory and quality control. You have what we call in a plant, at least in a chemical plant, you have the laboratory information management system that controls the quality of your product. So it measures particular results in the plant, sometimes from analyzers, sometimes from just sampling and then measuring everything in the lab. And then these results are fed back into the production process, typically to advanced process controller or otherwise to the process operations, so they might use it. And the moment we start attacking that information, then we might create all kind of quality issues in the product. And quality issues are, of course, crucial for the plant itself because that impacts their customers. So that's important part. You have management and leadership. They're, of course, always important. But it's very much important that it's clear that management and leadership is promoting cybersecurity, is promoting cybersecurity awareness, that everyone works on cybersecurity, knows that management wants that.
Okay.
Requires that, demands it. And that's something you also see in plants sometimes going wrong. They think about policies and they issue policies, but there is no sign-off of senior management. And then such a policy, it has little value over time. People start ignoring it because there's no correction anyhow. There's, of course, a lot of supply chain and logistics is important. If you look at the systems that manage your raw material inputs, your shipping, your docking, all that kind of stuff. There are lots of systems doing that, and they depend on process automation information, and reverse process automation systems depend on information coming from those systems.
Okay.
So it's crucial that these systems are also looked into. Then you might say HR, human resources, whatever do they have to do with it?
They can address the internal threat also by hiring a
Yeah.
right person for the candidate position.
But if you look at all of these teams and you look at the idea that all need to be aware, security aware, then there is only one team that actually can enable that, and that's human resources. Yeah? They should force that everyone does the proper training courses, does the proper awareness courses, and keep record of that.
True.
So this is a lot of teams, and then finally, all the other teams were internal teams, but you have the external stakeholders. You have very often you depend on vendors because you have bought particular equipment. Your vendor might provide their services for that. They might provide repair. They might advise you on all kind of stuff. So also external stakeholders are of importance. If you look at how much information on your system is sometimes stored at the external stakeholder, that's tremendous. So an attack on the external stakeholder security systems might also reveal a lot of information on your system that can be used by a threat actor that wants to attack your system. The most famous attack, I think, I don't like to mention it that often because it's so long ago and it's really a very special type of attack, was Stuxnet.
That is a live example, is TechNet, which basically give attention to OT security.
Yeah, but if you look at that, and you look at it from the Iranian perspective, there were a lot of external stakeholders that must have had a lot of information on their system.
True.
Yeah, because the attack was very precise, modified very much their internal software. Well, that is probably not only available from an external stakeholder. So external stakeholders are critical in all cases, and their security is critical. So when you do deep defense, then you have to look at all these aspects in a risk perspective. Where are the hazards? Where are the mitigations possible? Where are improvement possible? And nowadays, I have the feeling that if we talk about cybersecurity risk, we focus very much on the process automation system, and there's a red bubble in the middle. Ignore too much the other disciplines and the other influences.
Okay.
And I can give examples of each of them, but that takes too much of our time, I guess. But this is what actually deep defense is looking at all these aspects and addressing all these aspects and looking at where are the hazards and where is the biggest risk for the plant.
Until unless we don't know the discipline requirement, we cannot implement controls, and that is the most important rule we can say. Yeah.
And it's very important that all these disciplines work together.
True.
And that's also not the case. If you look at the plants, I've been in plants, and then we did a security risk assessments or safety or other types of risks, other types of assessments. And then you come at places and then you point to particular equipment. What's this type of equipment? And then the answer was, I don't know. No, but it was computerized. It was network connected. And then it appeared to be a piece of equipment installed by the power operations people. But one team focused on security for process automation, and the power operations team, they focused on not on security in that case. They focused on their technical problem to solve it with a particular piece of equipment. So it's very important that all these teams work together, and that there is a kind of a single responsibility for cybersecurity of a plant.
Okay.
And that is the holistic view of deep defense is looking at all these assets and where can we mitigate them and how can we improve risk, reduce risk, let me say it like that.
That's great.
Yeah. So what's the deep defense process? Well, you typically have to do a risk assessment, and then you have to look at how can you reduce your probability, how can you reduce your impact, and that you focus a little bit on the various risk factors there are. You can focus on the various risk domains. The risk domains are the OT physical risk, the cyber physical risk, and the socio-technical risk. And that are the three risk domains. The risk factors I showed in one of the earlier slides. So you have to look at all these hazards and all these, identify the hazards. You have to try to quantify these hazards so that you can prioritize. So probability reduction, impact reduction, and then you create kind of your layered protection. So even if your automation system is breached, maybe you can prevent that there is a massive damage in your physical system under those conditions. And of course, important if you have your layered protection that you monitor your risk. You need to stay aware of all your changes in the threat. The threat landscape changes. If you look in the European context, we have the conflict with the Ukrainian-Russian war. That has a change on the threat landscape. A change on intentions of threat actors, what they are willing to do and what they're not willing to do. It's changed in that sense, and so you have to do that, and then you have once in a while you have to restart that process. You have to redo a risk assessment. I've been at plants that asked, did you do a risk assessment? Say, yeah, we did a risk assessment, and then it appeared that the risk assessment was 10 years old or something like. Well, there's a lot of things have changed in 10 years.
True.
And even their system changed in 10 years. Where nowadays many of the systems are implemented in virtual environments. Well, 10 years ago that was not the case. So even technology changed. So risk assessments need to be redone time after time. So that's a little bit what I wanted to discuss. Not so much in detail, everything, but more the process of what is deep defense, and be aware that when you don't do it, when you only rely on your OT security in the sense of your automation system security, then you're probably sooner or later will fail. So you need multiple layers to, even if the first layer fails, that the second layer is there. Is there to help you a little bit. So these are some reasons why deep defense, so the multi-layered protection, resilience throughout the system, it creates a much better security awareness because everyone is involved in that concept, adaptability and flexibility, cross-functional collaboration between all these teams.
So are we using any framework here, Sinclair, like, or do you have your own custom frameworks which promote this deep defense, or we are following any industry standard frameworks and all that?
Well, I would say there is not really a single framework that has it. If you look at ISO framework 27001, then of course that covers everything, but it's not very specific. Not. And most, if you look at IEC 62443, that is also very general, but it doesn't cover the physical parts. It hardly covers the socio-technical part. Parts of it does, but it doesn't look at the organizational parts.
Understood.
At this time, there is not really a single framework covering it all. It's but parts of it have standards and frameworks. It's adding things together.
Understood.
I think this is the last slide, apart from discussion and questions.
That is really eye-opening for me, at least, because I have zero visibility on deep defense. I was in an impression of defense in depth, but thanks for taking out the time for this discuss this topic. And I could not find such content on YouTube also, so I'm sure it can be a, a informative for the people who are in OT security or who want to pursue their career in OT security. But there is one question, this is a question which is received from my subscriber and all that. How someone from a non-IT background can do the transition to OT security, or what do you see the OT security as a future in next 10 year or 5 year?
Yeah, that's a very interesting question, by the way, because I worked for a security team for more than 20 years. And that's always the question. Do you want to have people coming from the inside, what in our case was people with a real, very strong OT background, people from field service or engineering in OT, or do you take people from the outside, from IT, who have a very good focus on networks and IT security type of thing, Windows environments? I think it's a mixture. I think personally, I believe it's not possible to have one type of perfect OT engineer that is skilled in all things. Yeah, you can do that, but the moment you get close to reaching the level that you know everything, then you retire probably, because that takes a long time to do that. So
Agree.
I think if someone wants to move from IT into OT, well, he should learn the basics. And
do you have any recommendation to learn basics? Just if you can.
I personally would say always try to find a job in the OT environment and grow into it like that. I've had many questions like that in LinkedIn. People approach me and ask me for advice on that. And I find it very difficult. I've tried sometimes advice. I advise them some SANS course.
But any holistic response, if I say like a very generic response, take example like for cybersecurity, you need to have very good understanding with networks and all that. So do you have any recommendation from that point of view? How there will be some specific skills that you must be master on it, or you need to have a prerequisite?
I think the main thing, if you talk about deep defense and holistic approach, the main thing is not, and that's maybe also bad advice, but not to specialize too much. You have two types of people. You have people that are really very, very, very specialized in one topic, and they know everything about that topic, but they forgot about looking at the environment. You always have to try to understand why is something used and why is it used in a particular way. When I worked at my employer for all these times, basically from day one, I was trying to find out, okay, we have a process control, but what are you doing with it? Always there was always time to, if I did some repair somewhere, always time to talk with process operators or other people to understand a little bit on what they were actually doing. And then that's important. It's important to know, to understand why things are used and not to focus too much. If you lay your whole life in the grass, looking at the grass, then you forget the forest around it. You have to, sometimes look into the wider circle, and that some people are missing that. Some people really, I know people from my own environment that are really tremendous good in Windows, and they talk about Windows domains, and they have all the certifications, and they know very well on how that works and where the problems are and how to mitigate that. But the moment they stepped away from the domain, they were kind of lost.
Understood.
And in a holistic approach, that's not possible. You need both people. That's it is not like you can forget about the specialist, but you also need generalists. You need people that oversee things and can tie things together.
And how you basically take that as a reference of implementing, that's also important, because I've seen a lot of people have a different perspective about taking OT security. And what about the future of OT security? How you see the future? Like, no one has thought about cybersecurity will be rise like that. So how do you see the OT security as a future?
Yeah, that's another difficult question. I hope, I
Uh-huh.
personally hope, I don't expect it, but I hope OT security will disappear one day. If
Oh,
if
really?
the if the security is good enough,
Uh-huh.
that it becomes very difficult to breach. If you look at the OT environment,
Mm-hmm.
much of it is very specialist tasks, so it must be possible to properly secure it.
Okay.
If we look at the OT security system today, there are a lot of areas in the system that are very badly secured. That is partially historic reasons
Hmm.
and partially technical reasons.
Understood.
But that would improve over time. So I hope it improves, and then at a certain time we have it under control.
Hmm.
Because OT security should be easier than IT security. IT
Okay.
security has lots more users, lots more external interfaces.
Hmm.
So it's a lot bigger exposure than OT security. And OT security is mainly a problem, I would say, because of, first of all, of course, the impact, the potential impact, but from a security point of view,
Mhm.
that there are too many components and too many protocols used that are not secure enough.
Not secure enough. True.
And that we need to change. And that takes time. That's another problem in OT world, is that changes take a lot of time.
Hmm.
In IT world, you can make much more quickly a change. You can change your server or your desktop every
Hmm.
3, 4, 5 years.
Hmm.
In an OT environment, your installation lasts 25, sometimes 40 years.
Yeah, that's true.
And some components you can improve, but that impacts other components. There's a lot of dependencies.
Hmm.
So it's much more difficult to
Implement it. Okay. Yeah. Thanks, Sinclair, for this particular session. And I'm sure it will be a very, people also love this session because I got 2, 3 insights about OT, and I'm sure this content will be very useful for the aspiring OT security professionals. And taking out the time in a weekend is really uh, big things, and giving back to the society, giving back to the things which people need. It's kudos to you.
Weekends only exist for people that work, When people retire, it's just 7 days.
You are not retired because I can see your efforts, you putting your initiatives and all that.
Oh, yeah.
That's reach out to that. That's the reason. And
That's
keep
just for fun.
continue your work because I don't know, but I'm the one of them who got inspired by your content, your insights, your ideas.
Thank you very much. Thank you.
And team, do let us know. Shall I disturb again Mr. Sinclair for another topic? So I can try to invite him again on this session to discuss those topics. I believe Sinclair is okay with that.
Yeah. If you have a specific topic, I can look at that. That's fine.
Thanks. Thank you so much,
We
sir.
didn't agree on a topic, so now I took some general topic, but
Definitely. So, team, we can see a lot of interaction in future also from Mr. Sinclair. And thanks again. And Sinclair, you have a lot of fans from India. Trust
yeah.
me, and we really admire your work that you're doing in OT security. Keep up the same work.
Okay. Thank you very much.
Thank you. Thank you so much, Sinclair, for your time.